Astronomers confirm dark energy and restore confidence in the accelerated expansion of the universe.
Recently, a new study brought relief and reinforcement to one of the most important discoveries in modern cosmology.
Astronomers confirm that the universe continues to expand at an accelerated rate, thanks to the mysterious dark energy, an invisible force that drives this acceleration. This comes after a major scare at the end of 2025, when controversial research suggested that this energy might be weakening, which would shake decades of scientific studies. Led by the University of Southampton in the United Kingdom, researchers carefully reanalyzed the data and concluded that the original measurements were correct. There is no indication that the universe is changing its behavior. The work, published in the journal Monthly Notices of the Royal Astronomical Society, involved Nobel Prize-winning astrophysicists such as Riess and Schmidt, who helped discover the accelerated expansion in the 1990s. It all began with Type Ia supernovae, extremely bright explosions of white dwarf stars that serve as standard candles for measuring immense distances in the cosmos. Astronomers use the brightness and redshift of these explosions to calculate how far the universe is moving away. The 2025 research had hypothesized that these supernovae changed in brightness over time, which could indicate that the expansion was not accelerating, but perhaps even slowing down. If true, it would completely change our understanding of the fate of the universe. However, the new analysis identified problems with this interpretation. Scientists realized that the previous study confused the age of galaxies with the age of the exploding stars. Furthermore, it did not adequately consider the mass of the host galaxies, an important factor that modern studies now include for greater accuracy. By correcting these points, the results once again strongly support the existence of dark energy and cosmic acceleration.
The lead author, Dr. Phil Wiseman, explained that the debate arose from a misunderstanding in the way the data was analyzed, and not from something wrong with the universe itself. The old measurements were correct and our understanding of the future of the cosmos remains solid, he said. Now we can go back to investigating what dark energy really is, instead of questioning whether it exists. Professor Riess reinforced that extraordinary claims require rigorous testing, and the data confirm the consistency of the acceleration. This confirmation is important because dark energy represents about 70% of the universe, but it is still a great mystery. Nobody knows exactly what it is. It could be a property of empty space or something more complex. Questioning established ideas is part of the scientific method, as Professor Mark Sullivan pointed out. Even though the 2025 hypothesis was not confirmed, it helped refine methods and improve our understanding of how supernovae work. Ultimately, the universe continues to expand ever faster, as current models predict. This discovery reassures the scientific community and paves the way for new investigations into this enigmatic force that dominates the cosmos. The quest to understand the universe continues steadily, with more questions than answers, but with a more solid foundation than ever before.